Hey guys, so here's the news for 10.3. We are now going to be talking about probability, specifically about theoretical and experimental probability. Okay, so probability of an event. It's the measure of the likeliness or chance that an event will occur. So you might always hear like, oh, the probability of something happening. Okay, that's basically the likeliness or chance that that event will occur. Now, basically, the formula that we're going to use for our probability, there's two different types. We have theoretical and experimental. So for theoretical, we do the number of favorable outcomes, so what we want, all over the total number of outcomes. So how many there are. With experimental, that's the number of successes. So how many of those things that we want over the number of trials. Now, with theoretical probability, it's based on the reasoning in which likely outcomes are counted. So basically what would happen in a perfect world. While experimental, which of course you're doing an experiment, it's based on the results of an experiment, a survey, or the history of the event. So for example, let's talk about flipping a coin, okay? So there are basically two parts of a coin. You have heads and tails. So let's say you want to figure out what's the theoretical probability of landing on heads. Well, since you have two sides, that's the total number of outcomes. Your favorable outcomes, which is the heads, is 1. So that's 1/2, or 0.5. But if we did an experiment and we flipped the coin multiple times and we wanted to figure out what is the probability of getting heads, then how many times we actually got heads when we did the experiment over the number of trials or number of times we flipped it. So that means actually your experimental probability might not be exactly the same as your theoretical. Now, when we talk about probability, it is going to be either as a fraction or decimal. You can do either or. You can write the probability of an event, as I said, as a fraction, decimal. Usually, we're not really going to write it as a percent, okay? But just as a fraction or decimal. Now, for a fraction or decimal, it will always be between 0 and 1, okay? So 0 means that it's never going to happen. Anything between 0 and 0.5, it's less likely. 0.5 means we're equally likely to happen. So just as we did with flipping the coin, it's equally likely, theoretically, to flip heads or tails. Now, if we get above all the way to 1, that's more likely something's going to happen, and 1 means that it is definitely going to happen. Okay, let's go ahead and do a couple examples here. So probability of rolling a 5 on a 6-sided die. Now, this is using theoretical probability. So let's just think about a 6-sided die. So we have 6 sides total. So theoretically, like in a perfect world, okay, what would be the chances or what would be the probability of getting that 5? Now think about how many 5s are on that 6-sided die. Well, there is only one side that has 5. Now, how many sides does the cube or the die have total? 6. So basically, our probability of rolling a 5, theoretically, on a 6-sided die is 1/6. Now, this could be a little bit different if we did an experiment and we rolled the die a lot of times or numerous times, then our probability could be a little bit different. Now, as I said, you can either write it as a fraction or a decimal. Now, when you write it as a decimal, just read the instructions. It might tell you where to round to specifically. I'm going to round to 4 decimal places, so I have 1, 6, 6, and 7. So don't forget to make sure you round up there. Okay, now let's talk about probability of rolling an even number. Okay, number of ways to roll an even number. So this is still on a 6-sided die. So let's think of all the even numbers. We got 2, 4, and 6. So that is 3. Now, how many sides does our die have? Okay, there's 6. Now, when you write it as a fraction, make sure you simplify that fraction, just like we do always in math. So really, this is going to be 1/2, or if we want to write it as a decimal, 0.5. And since it terminates, we don't really have to write it as 4 decimals, just write it as it is. So we have 1/2 or 0.5. So it's equally likely to roll an even number. Okay, now those are dealing with theoretical probability. Let's do some with experimental probability. So here you roll a die 100 times, here are the results. So this is what we call experimental. Because you actually did an experiment and rolled that dice. want to talk about. This is theoretical. Okay, so now using this information, let's see a number of times a ruling of 5. So we noticed to roll a 5, we did it 14 times, okay? Now we need to talk about, well, how many times did we actually roll? So in order to get the total number of times rolled, we will need to add up all these numbers here. So we will need to add up the 22, the 18, 15, 12, 14, and 19. Actually, we don't need to do that because it told us we rolled it 100 times. But you can also add them as well, and it should add up to 100 times anyways. So 100, because that's what they told us. But you can also add it up. Okay, don't forget, we need to, if you write it as a fraction, put it in simplest form. So the number that goes into both 14 and 100 is 2. So I have 7 over 50. Now, if you want to, you can also write that as a decimal. So 7 divided by 50, like it says 0.14. So notice this is a little bit different than what our theoretical probability. Actually, the idea is that if you keep rolling it to infinity, then the experimental probability will then get exactly to be about the same as theoretical probability. Okay. Now let's talk about rolling an even number. So remember, even numbers are 2, 4, and 6. So looking here, we will have to use the 2, the 4, and the 6. Now that means we actually have to add up the 18, the 12, and the 19. So put that into your calculator, and when you do put that into your calculator, you should get about 49. So we have 49 over, and we rolled this 100 times because it told us in the problem. Okay? And really, there's no way of simplifying this, so we're good to go. If you want to write it as a decimal, okay? Now remember, theoretically, we got 1/2. Here, we got very close to that 1/2 or 0.5. We got to 0.49. So as I said, if you actually did this experiment in infinity times, your experimental probability will get to your theoretical probability. Okay, last one, let's do probability of number less than a 3. Okay, so this one, I actually would like you to pause the video and do this one on your own. Okay, let's see what you got. So less than 3, that means we do not include the number 3. We want all numbers that are smaller than it. Okay, so for this, to get the number, so we are looking at the roll of 1 and the roll of 2. So we add up the 22 and the 18. And that's going to give us 40, and we put that over how many times we rolled, which was 100. Okay. So as I said, don't forget to simplify your fractions. So this should actually be actually even smaller than that. I believe to be 2/5. And then if you want to write it as a decimal, you can put it as 0.40. Okay. Okay. We have one more to do here on this part. We are now going to be talking about cards to do our next part, right? So go ahead, actually make sure watch part 2 of this video, and we're going to do more of the theoretical and experimental probability. Okay, see you then.